Hello everyone, welcome to the physics online class, and we will continue the last session today. The next numerical we are going to solve today is 2.3 in the NCERT book. Two charges 2 microcoulomb and minus 2 microcoulomb are placed at points A and B 6 centimeter apart. First question, identify an equipotential surface of the system. Second question, what is the direction of electric field at every point of the surface? See dear children, already in the theory class we had a discussion over what is the meaning of the equipotential surface and what are the properties of the equipotential surface, right? And here they have given two charges, one is a positive and another one is a negative. That means it form like a dipole. Then what is the nature of equipotential surface we need to draw here? That is our first question. Identifying means that we should draw. Then the second one is, what is the direction of electric field to the every point of the equipotential surface, right? First question we solve here. Solution, this is a diagrammatic related solution for charges 2 microcoulomb and minus 2 microcoulomb. Equipotential surface is see here, one is positive, another one is negative, so it forming the dielectric, so dipole. Therefore I can use here is a point A, this is a point B. That means it is for a positive charge, this is for the negative charge. How will be the equipotential surface? Identification of this is like this. For the dipole, electric dipole, the equipotential surface appears to be like this. And second question, what is the direction? We learnt that the direction of the electric field is normal to the every point of the equipotential surface. Therefore, for the answer of the second question is, it is means what? Electric field is normal to the every point of the equipotential surface. Is that clear? Yes. Coming to the next question 2.4. A spherical conductor of radius 12 centimeter has a charge of 1.6 into 10 raised to minus 7 coulomb distributed uniformly on its surface. What is the electric field? First, inside the sphere. Second question, just outside the sphere. Next question, at a point 18 centimeter from the center of the sphere. See dear children, this question is related to the electric field of the uniformly charged spherical shell. And about the theory we know, inside a uniformly charged spherical shell the electric field is 0. That is why the first answer for this question is 0. Then how to calculate the electric field at just outside the sphere? Means it is on the surface of the sphere, right? And this is at a point 18 centimeter away from the that center of the sphere. So, in numerical, solving the numerical, we need diagrammatical representation that helps you a lot to understand the given situation, right. So, let us solve that with the diagram. Assume here is a spherical shell or the sphere, yes, and when charges are given to this, they are distributed uniformly on the surface of the sphere, right, and take this is the center of the sphere, call it is the O, and this is the radius of the sphere, call it is the R. And let us take, there is a point P or A, anything you can choose here, at which point this is at a distance 18 centimeter away from the center of the sphere. Okay. So, then how to solve? For first answer is 0 only. Electric field inside a uniformly charged shell is 0. Then what about the second? For the second question, electric field at just outside the sphere is E is equal to 1 upon 4 pi epsilon naught Q upon R square. See dear children, this formula you know already, but here I have taken capital R. Why? Just outside means it is just on the surface of the sphere, that is why it becomes R. So, this is the R square. Then substitute the values here. 1 upon 4 pi epsilon naught means directly you can take its value as 9 into 10 raised to 9 into charge they have given here 1.6 into 10 raised to minus 7 coulomb upon the radius of this given sphere is, it is 12 centimeter. 12 centi means 10 raised to minus 2 whole square. Yes, after the simplification you will get the answer here. This is our first step, right. Then next one, yes dear children, I will ask you in the our given assignment or in the next video, what is the answer of this electric field, remember that. So, you should watch the video first and solve this and keep the answer with you, right. Yes. The next question is, at a point outside the charged sphere means the electric field is given as E is equal to 1 upon 4 pi epsilon naught Q upon R square, because this is taken as a small r. So, small r value is how much? That is equal to 9 into 10 raised to 9 into same 1 upon 4 pi epsilon naught means 9 into 10 raised to 9 into Q means the same charge only 1.6 into 10 raised to minus 7 upon, so here R value is 18 centimeter, 18 into 10 raised to minus 2. After the simplification you will get the value of the electric field, that is in Newton per coulomb. Here also Newton per coulomb. Are we getting, my dear children? Yes? Hope you all can solve this and get the answer. Right. Okay. Let us move to the next question, that is 2.5. This is related to the parallel plate capacitor. A parallel plate capacitor with the air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half? and the space between them is filled with a substance of dielectric constant 6. See dear children, when in the first video I told you very clearly, when numerical comes, first the concept, theory concept what you discussed, what formula is there, you should come in your mind, right. So, when you decide a proper, an important formula of the given numerical, definitely you can solve it easily, right. Then this concept is belong to the parallel plate capacitor, right. What is the formula linked with this? One is when the plates of that capacitor filled with the air, we have Ca is equal to, or C naught is equal to, or simple C is equal to epsilon naught A upon D, that is our formula. Then when the same capacitor is filled with some other material with a dielectric constant, then definitely there is a change in the capacitance, there is an increase in the capacitor. So, what is the formula there? C D or C dash is equal to K into epsilon naught A upon D, right. Then it is this is the, so what the formula, then by using this all the data is given, just substitute and get the answer, right. Then what are the given values here? Given values are, so first they have given when it is filled with the air, Ca or C naught is equal to, or Ca is equal to 8 picofarad, they have only given, right. Then what will be the capacitance, means new capacitance C dash we have to find. When condition is mentioned here, the distance between the plates is reduced, means beginning the distance was D, now the distance is reduced, means D by 2, the new distance is D dash is equal to D by 2, okay. And there is a dielectric medium of dielectric constant 6, right. So, using the formula, using Ca is equal to epsilon naught A upon D, okay. Then C dash is equal to K into epsilon naught A upon D. It is equal to, see, if you call this is equation number 1, then this is equal to, this is nothing but they already mentioned it is 8 into picofarad. 1 picofarad means, remember children, 1 picofarad is equal to 10 raised to minus 12 farad, right. So, then this value already they have given. So, in the place of this I substitute here K into Ca or C naught, then C dash, sorry, here the distance should be is equal to D dash, because here it is filled with the air and normal distance and area was there, but now the condition is changed. What is the condition? Dielectric constant K is kept and the distance is changed, it is reduced half. So, this becomes K into epsilon naught A as it is, D dash means we know that D by 2. Then when you simplify here, it becomes 2K epsilon naught A upon D. Then this term you can replace by using equation 1 as C dash is equal to 2 into K into Ca. This is nothing but 2 into K is 6 and Ca means 8 picofarad. Then 6 2s are 12, that means it becomes 12 8s means 96 picofarad is the answer for the new capacitance. Is that clear, dear? Right. Yes. Then let us moving to the next one. Any doubts you can ask me personally or you can comment me on the video. Okay? Yes. And come to the next numerical 2.6. 3 capacitors, each of capacitance 9 picofarad are connected in a series. First question, what is the total capacitance of the combination? Total capacitance. Second, what is the potential difference across each capacitor if the combination is connected to a 120 volt supply? See dear children, last numerical was related to the parallel plate capacitor, and there is a lot of difference between parallel plate capacitor and capacitors connected in the parallel combination. Okay, and it was explained very clearly in the theory classes too. Yes, and here now there are 3 capacitors, each having 9 picofarad as a capacitance. All the 3 are connected in the series. Now what is our question? What we need to calculate? Total capacitance. Total capacitance is also called equivalent or effective capacitance. That is our first question. Then the second one is, what is the potential difference across each capacitor if it is connected to 120 volt? That means V1, V2, V3 value we need to calculate, right. Then what formula need to apply here? They are connected in the series. Yes, suddenly you should remember the formula. 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. That is to find the effective capacitance. Then using that only you can find the potential, right. Then for this, the diagrammatic representation you can give as capacitors, 3 capacitors are connected in series. All the 3 have 9 picofarad. This is also 9 picofarad, call it is a C1, C2, C3, all are of 9 picofarad only. And you know that across them the potential is V1, V2 and V3. Okay. So then firstly what we need to calculate, given that as you take down dear children, given is C1 is equal to C2 is equal to C3 is equal to 9 picofarad. All the 3 have same only, and the potential, total potential is equal to 120 volt, right. Firstly we need to calculate what is the Cs, then next one what is the value of V1, V2 and V3, right. Then let us continue its part here. Yes, what is the formula? The total capacitance one upon Cs is equal to 1 upon C1 plus 1 upon C2, 1 upon C3. Then 1 upon Cs is equal to 1 by 9 plus 1 by 9 plus 1 by 9, that is 3 by 9, 3 1 ja 3 3 ja 1 by 3. Then if you take the reciprocal of this, Cs will become 3 picofarad. Yes dear children, what is the total capacitance? It is 3 picofarad, right. You can write pico or you can mention 3 into 10 raised to minus 12 farad also, no problem. Okay. Then this combination is connected to a potential of 120 volt. Then how to find the, we know that in the series combination or else in this series two parallel combination of the capacitor. You only have to solve and send